Hi, today we are learning complex number on an Argand diagram. So here if you see that x-axis is here, uh, which is showing real part, and y-axis is showing imaginary part, and this is complex number z equal to x plus iy. The complex number z x plus iy is represented on the diagram, and there is a point P here, suppose, and which is representing complex number x plus iy. So today what we are going to learn, we are going to represent complex number on an Argand diagram. So let's start our question number 1. So our first point is z1, that is 3 plus 2i. So we are moving 3 steps here, 1, 2 and 3, and 2 steps on this imaginary axis here. So let's draw it points. So 3 and 2. So this is our point on 3, and there is another point and 2. Okay, so this point will be z1, and that is 3 plus 2i. Yeah. Now let's see another point, that is minus 4 plus i. So we are moving minus 1, minus 2, minus 3, minus 4 here, and one step down, that is here. So we are going to draw lines now. So minus 4 and plus 1. Sorry, this is plus 1 is up. So minus 4 here and plus 1. So this is our next point here. So this is z2, that is minus 4 and plus I. When there is I, so it is 1i, so we can go 1 unit up. So this is done, this is done. Now we need to see z3 equal to 2 minus 3i. So 2 steps here and then minus 3. So you are going down minus 3. Yeah. So 2 forward and 3 down. So let's do it this way. So 2 steps here and minus 3. So we need to start from here. Okay, and minus 3. Yes, that's better. So it is 2 minus 3i, and that is z3. And the last one is minus 4 minus 3i. So minus 4 is here and minus 3 is here. So we can take this as well. So minus 4 and minus 3. So this is minus 4. Okay, and this is minus 3, right? So let's join them. Yes, that's better. So this is z4, that is minus 4 minus 3i. Okay, so this is the way we represent complex number on an Argand diagram. Okay, now let's go for another question. So addition of complex number. So let's take our first example. z1 equal to 4 plus I. Okay, and z2 equal to 3 plus 3i, and we need to add them. So here complex number always follows the vector addition. Okay, so this is real part, imaginary part. So z1 you can write down like this: 4 is real and 1 is imaginary. And z2 you can write down 3 is real part and 3 is imaginary. So if you need to find z1 plus z2, just add. Z1 is 4 and 1, then plus sign 3 and 3. So 4 plus 3 becomes 7, real part with real part, imaginary part with imaginary part. So 1 plus 3, that is 4. 7 and 4. If you don't want to follow this, so you can follow this way as well. Okay, so Z1 plus Z2, Z1 is 4 plus I and Z2 is 3 plus 3I. So you are taking a real part with real part. 4 plus 3 is 7 and this I and 3I becomes 4I. So it's up to you how you want to find it here. Now our problem is how to represent this on an Argand diagram. Okay, so we have seen already how to represent Z1 on Argand diagram, Z2. Now we are learning about the addition, how to put two complex number if we are adding on a Argand diagrams. Let's see. So we are going to represent this 4 plus I and 3 plus I, and so first vector is 4 plus I, so we are moving 4 steps forward and 1 steps this side here, 1 steps on imaginary axis and 4 steps here. So our points will be this one, so 4 plus I, so this will be point, okay, and the next point will be this one. You can draw the dotted line if you want. So this is 4 plus I. Okay, so this is what we have done. So this is representing Z1. So if we draw a diagonal line from here, diagonal line, so like this, here it is. Okay, so this is representing Z1. So suppose this is O or 0 and this is point A. So OA, this is representing Z1, right? So let's write down here Z1. O is representing Z1. 4 steps on real parts and 1 steps on the imaginary part in positive direction. Next one is 3 plus 3I. So 3 here and 3 here. So we can construct it quickly. 3 plus 3I. So this is 3. Okay, and the next line we can draw it quickly. Okay, and diagonal line. So this will be like this. Okay, so this is showing Z2 vector. This is Z1 and this is Z2. Now, the resultant, as I told you, complex number follows vector addition rule. Vector addition rule. Okay, so when we join two vectors, so head of first vector joins the tail of the other vector. So here, because this is vector, so we can draw another vector which is parallel, okay, parallel to this vector, right? So, and our diagonal, if you add Z1 and Z2, so Z1 and Z2, 4 plus 3 becomes 7, 7 plus 4I. So 7 is here and 4I will be there. So it is coming here at this point, 7 and 4I, right? This will give you Z1 plus Z2. So I'll show you one by one. So Z1 is 4 plus 3, 7 plus 4I. So we are going until 7 and 4I, right? And we can join them. Now, if we construct this parallelogram, if we shift this Z2 in this direction, then let's take line from here. So like this. This is exactly like Z2 here. because this is head of the first vector, it is joining tail of the second vector. So this is z1 and this is z2, and their resultant is given by z1 plus z2, and you can join them. You can join them. So if you want, you can draw the dotted line. Okay, so this is giving parallelogram. So addition is always represented the diagonal of the parallelogram. So z1 plus z2 is 7 plus 3i. Okay, now if we want to do another example, like let's take z1 equal to 8 plus 4i and z2 equal to 6 plus 7i. Yeah, so how we are going to do this? So let's construct the axis for this. So here z1 is 8 plus 4i, z2 is 6 plus 7i. So I have taken z1, that is 8, and here it is 4, 8 plus 4i. So this is representing z1. Yeah, so let's draw a line. Okay, so this is z1. Okay, z1 is this green line. Now the next one is z2. z2 is 6 plus 7i, so 6 here, and 7 will be on this axis. So 6 and 7, it will come here. So let's construct a line with different color. So yeah, so let's do z2 equal to 6 plus 7i. So basically it is 7 plus 7i. So let's change it here. It is 7 plus 7i. Yeah, so we can change it. So it is 7 plus 7i. So 7 here and 7 here. 7 plus 7i, right? Now we need to find z1 minus z2. So how we are going to find z1 minus z2? With z2, if you see here, it is coming negative sign. So it means you need to reverse this direction, z2, then it will be coming in this section. So what will be the coordinates here? First, second, third, and it is coming in third coordinate. What will be the coordinates of 7 plus 7i here? Yeah, so it will be 7 and 7. So change of this sign, so it will be minus 7 and minus 7i. So minus 7 here and minus 7 here. So minus 7 and minus 7. So if we draw a line, minus 7 and minus 7, so it is coming here. So this is minus 7, and we can draw another line here from here till here, minus 7. Yeah, so this is giving you z2. So z2 with black ink, right? So just join this. Okay, so this is giving you z2, negative z2. Now we need to find z1 minus z2. So this is our z1 and z2. So z1 minus z2, how we can find it? Yeah, so see here, their resultant. Let's find what is z1 minus z2. So z1 is 8 and 4. So write down here 8 and 4, then minus sign, and z2 is 7 and 7. So 8 take away 7 is 1, 4 take away 7 is minus 3. So it will be 1 and minus 3. So we can draw it here, 1 and minus 3. So this is 1 and minus 3. So in front of 1, okay, and then next line will be like this. So minus 3. So their resultant is given by 1 and minus 3. So you can join them. Okay, so this vector is representing z1 minus z2. Okay, and if you can join them like this, so this will give you a parallelogram, right? So this will give you parallelogram z1 minus z2. Okay, now I'm giving you two practice questions, and you can solve and show it on Argand diagram. So here you go for your practice question. Yeah. So Z1 is minus 2 plus 5i, Z2 is 7 minus I. Show Z1 plus Z2 on an Argand diagram, and here Z1 is minus 5 minus 5i and Z2 is minus 3 plus 4i, and show Z1 minus Z2 on an Argand diagram. So can you pause the video and have a go? Welcome back if you have tried. So your answer is here Z1 plus Z2, that is 5 and 4. So if you add minus 2 and 7, then it will be 5, and 5 take away 1 is 4. So you move 5 steps here on real axis and 4 steps on imaginary axis, 5 and 4, Z1 plus Z2. Here Z1 is minus 5 and minus 5, so you can see minus 5 and minus 5, and Z2 is minus 3 and 4. So because here with Z2 is negative sign, so you can reverse the direction, so sign will change. So instead of minus 3 it is going on 3, instead of plus 4 it is going on minus 4. So this is showing you minus Z2. Okay, this is minus Z2. Now Z1 minus Z2, so minus 5 minus and minus minus becomes plus. Minus 5 plus 3 is minus 2. Minus 5 minus 4 is minus 9. So you go on minus 2 and draw here minus 9. So this will show you Z1 minus Z2 on Argand diagram. Okay, so I hope you know how to represent single Z1 on Argand diagram, Z2 on Argand diagram, their addition Z1 plus Z2, how to represent on Argand diagram, and Z1 minus Z2 on the Argand diagram. So these 4 things we have learned in today's video, and next video we are going to learn about modulus and argument of the complex number. Till then, goodbye. Thank you very much, and thanks for watching.